Hello students, welcome to Tutitut. We have seen some questions from the power plant engineering and similarly from the electrical circuits or networks concept. Okay, so in this session also we will see the networks questions. Okay, these are all some of the previous year questions only. Okay, let's see the first question. Kirchhoff's current law is based on the law of, okay, so KCL they are asking, remember these two. Okay, KCL is based on law of conservation of charge. Okay, so law of conservation of charge. So how it is? Law of conservation of charge. Okay, law of conservation of charge, it is KCL. Okay, similar to this, so KVL, what is KVL? Law of conservation of energy. Okay, so law of conservation of energy. Okay, so here Kirchhoff's current law they are asking. Current law means law of conservation of charge we need to give. Okay, so this is the answer. So KVL is this one. How this is means, see, KCL is based on law of KCL is based on the current. Okay, so algebraic sum of the currents at a node or junction is equals to 0. That means sum of all the currents are sending end current or not sending end, incoming current is equals to outgoing current. So what it is happening? Forget about the time. It may be instantaneous time, otherwise it may be average or it may be different. Okay, but every time, okay, so you see the charge in the network, it will be same only. Okay, like conservation of charge is happening there. Okay, like KCL itself, the statement of KCL itself is having law of conservation of charge it is. Okay, so how means the charge divided by the time will be given as the current. So time may be varying, there is no dependency on the time here, so directly we can give it as a law of conservation of charge. Okay, similar to this KVL also. Okay, so it's a conservation of energy. Okay, so some more explanation is also there, so no need in this question. So in a different question we will see. Okay, so next one, for the circuit given below, the current through 1 ohm resistor will be. Okay, so current through 1 ohm resistor they are asking here. So total voltage is 10 volt and here 8 volts is there, remaining 2 volt, then it will be satisfied. And if you think wrong, okay, definitely wrong. This is AC circuit and there is inductor already mentioned. So we need to check 10 volts is equals to under root voltage across this, for example V square plus 8 square is 64. So this will be the one. So V equals to 100 minus 64 is 36. So V equals to under root 36 you will be getting. So that means 6 volts you will be getting. Okay, so our amperes are volts it is. Okay, voltage is 6 volt. So current will be, so current I equals to V divided by 1, that is 6 amperes it is. Okay, so this is the answer for this question. Okay, next question, the time constant of the network shown in the figure is. Okay, so this is very important question, so they may ask this kind of questions definitely. Okay, so what they have asked, the time constant. What is the time constant? So this is RC circuit. So for RC circuit the time constant will be R equivalent into C equivalent. This is the time constant. Okay, here what is R equivalent? So R equivalent means these two are connected in series or parallel. How we need to check? So before all these calculations we need to have some considerations, like time constant we have to calculate before switch operation or after the switch operation. This is the first thing we need to know. Okay, so here switch is closing. So remember, whether switch is opening or closing, that will be a disturbance for the circuit, that will be a transient for the circuit. So here switch is closing. So whenever switch closes, then only there will be charge flow. Otherwise, whenever switch something happens, okay, like opening or closes, there will be some disturbance happens in the energy storing element. Here that is capacitor. Okay, so before it is normal only. Okay, because the switch is open means no problem, circuit is working properly. Now whenever something changed in the network, definitely some disturbance will occur. Okay, so leave it. So disturbance is occurring and we need to see the resistance of the network after switch operation or before switch operation. We need to get this clarity. Okay, see, whenever disturbance is happening, at that time we need to check the time constant. Okay, so here switch is closed. Okay, so what is the final state of the switch? Based on that we need to check the time constant. Okay, so remember, R equivalent or C equivalent, both you need to calculate after switch operation. Okay, switch operation means whatever switch direction is there, here switch is closing, that means it is a short circuit here. Okay, so that's for the circuit. Now what you need to do, we need to check the R equivalent. Okay, so R equivalent, from where you need to check, from this side or from this side or from this side, which side? So we need to check the R equivalent. So why we are checking this R equivalent means, in the capacitor some energy has been stored before only. Whenever disturbance occurred, some energy will go to the resistors. Yes or no? Wherever closed path is there, so that energy will be going to all the resistors or any other elements. So from the capacitor point of view, you need to check the R equivalent. Understanding? Wherever capacitor is there, okay, so open circuit this capacitor and check the resistance from this. Okay, so and resistance of voltage source is 0 ohms, so it will be short circuited. So R in parallel with 2R. Okay, so from this side, if you see R in parallel with 2R, if you consider this as the open, then what will happen? Only 2R will be there. But actually we need to check the time constant after the switch operation, whether that is closing or opening. Okay, whatever direction it is there. Okay, so that is after a certain time. Okay, so after the switch operation only we need to check. Okay, R in parallel with 2R, you will be getting as 2R divided by 3. Okay, so this is the R equivalent. Okay, similar to this capacitance equivalent, here only one capacitor is there, so directly C equivalent is equals to C, we can give like this. But you observe, okay, so here also capacitance we need to check from the resistors point of view. Okay, so from the resistor side you need to check the capacitance. Okay, so that's what the C equivalent calculation. So now total it will be 3R into C divided by, okay, so not 3R, 2R divided by C. Okay, so 2RC divided by 3, sorry. Okay, so 2RC divided by 3 you will be getting. Okay, so this is the final answer. Option D is the correct answer for us. Okay, so option D. Okay, next one, consider the star network shown in figure. The resistance between terminals A and B with C open is 6 ohms. Between terminals B and C with A open is 11 ohms. Between the terminals C and A with B open is 9 ohms. The values of A, B and C are, okay, 3 conditions they have given and they are asking about all the 3 resistances. Okay, values we don't know. So now what is the first consideration they have given? The resistance between the terminals A and B with C open. Okay, so C open, that means no need of this C. Okay, so C resistance no need. Between A to B, what is the resistance? They said RA plus RB you will get like this, so that will be equals to, so what is the resistance they said? 6 ohms it is, 6 ohms. Okay, so RA plus RB you need to get 6 ohms everywhere you are getting. Okay, so next second option, so the between B and C terminals with A open is 11 ohms. Between B and C, if you check like this, RB plus RC, okay, so RB plus RC you will get as, so 11 ohms they have mentioned. So from the options you need to check. Okay, RB plus RC. Okay, so no, not this option. RB plus RC, this might be answer. So this is not the answer. Okay, so in these two only our option is there. Okay, so next one, third option, another condition. Okay, so C and A with B open is 9 ohms. Okay, so that means RC plus RA, okay, so is equals to 9 ohms. RC plus RA equals to 9 ohms we got here. So this is wrong already. Okay, so RC plus RA equal to 9. RC plus RA equal to 15 here. So here this option is correct one for us. Okay, so you can check, cross check once. Okay, so within 1 minute only we have to do this kind of questions. Okay, next one. So unit of reluctance of magnetic circuit is reluctance. Okay, so reluctance, or they are asking what is the formula for reluctance? Reluctance is nothing but just like a resistance. Okay, so resistance we need to give, or based on the Ohm's law it will be voltage divided by current. The analogous quantities we need to mention here. For the resistance in magnetic circuit, reluctance. For voltage in magnetic circuits, magnetomotive force, MMF, and for the current, the analogous quantity in magnetic, it will be flux. Okay, so reluctance equals to MMF per flux. Okay, so like this we need to give. mmf units are ampere turn. Okay, so flux units are Weber. Okay, flux units are Weber. Ampere turn per Weber will be the, so ampere turn per Weber will be the answer for this. Okay, here we need to know what are the analogous quantities. Okay, so here current, here flux, here current density, here flux density. Okay, so here another options also there. Okay, there are some more questions in this also, so there we will learn one more or two more points. Okay, so like analogous quantities also important for us. Okay, so like that we need to understand. Okay, so next one, in the circuit shown the dependent source, so dependent source delivers some power or absorbs some power, that's what they are asking. So this is a simple circuit, two meshes are there in this, and this is the dependent voltage source it is. Okay, so dependent voltage source it is, but current they have mentioned. Okay, so leave it, no problem. So they are asking about how much will be the power delivered by that source. Okay, so let's consider this as a voltage source only. Okay, so voltage source only, so then the voltage value will be V1 divided by 5 it is. Okay, so where is V1? V1 is, okay, so it may not be here. Okay, V1 is between these two. Okay, so between these two, because its value has been mentioned already, why they need to mention again? Okay, so this is 20 volts and this is V1, and here V1 by 5 amperes they have mentioned. Okay, so maybe it's we need to consider something. Okay, so we will consider this as a current source only. Okay, so that's more comfortable. Okay, so current source, if you can find out the voltage, then you can get the power delivered by this. Okay, so anyhow V1 is the voltage, so V1 is the voltage means current going inside it will be equals to V1 by 1 amperes. Okay, so that is the current, and here V1 by 5 amperes is coming like this. So how much will be the remaining current? So V1 by 5 will be coming like this. V1 is going, so that means V1 by 5 minus V1. Okay, so that much of current it should come like this. Otherwise if you calculate this current also, okay, so like V1 by 5 current is coming and V1 current is leaving. Okay, so like that we can consider. Okay, so like this kind of current it will be. Okay, current direction will be like in this direction. Okay, so now you need to apply the one loop equation. Okay, so I will apply in this one only. So like minus 20 plus V1 by 5 minus V1 into 1 plus V1 equals to 0. Okay, only this loop. Okay, nothing else I have did. So then what you will be getting, so total it is minus 20 plus, so here it is minus 4V1 divided by 5. Okay, so otherwise V1 get cancelled, so V1 by 5 equals to 0. So then V1 equals to, so 5 into 20. Okay, so it will be 100 volts. Okay, so 100 volts will be the, so voltage V1. Okay, so now what they are asking us, so they are asking about powered, delivered or absorbed by this dependent source. Okay, so power is equals to voltage across this one into current in this one. Okay, so current we know, what is the current? V1 by 5, V1 by 5. Okay, and voltage is nothing but what is the voltage across this? So as we have considered, this is V1. Okay, so V1 is nothing but 100 volts we got. Okay, so 100 volts we got, so 100 into 100 by 5. Okay, so then you will be getting 2000 watts. Okay, so 2000 watts you will be getting. Okay, so don't think like answer we got wrong. Okay, here maybe we have considered one problem, how whatever problem it is. Okay, we have solved this one in a proper procedure. Okay, so this might be some change will be there in this question. Okay, so let's observe. Okay, otherwise you can consider as a next problem. So you try this question. Okay, so as a another problem, as a voltage across this one. Okay, so voltage across this one will be, so V. Okay, so our V1 and current source value will be V1 by 5. That's we have considered now. So next you can try for the different thing. Okay, so like voltage source value is 20 V, and V we can consider here. Okay, so V1. Okay, so V1 we can consider here, and then you can check again a different kind of problem will be coming for us. Okay, so instead of considering this as the instead of the as a current source, okay, so you can consider as volts. Okay, so no need of this direction, then it will be a voltage dependent voltage source. Then again you will get different kind of problem. Okay, so anything you can solve, and you need to apply certain methods to get the power in this one. Okay, so you can try in a different methods also. Okay, next one, which of the following quantities is dimensionally different from the other three? Okay, so this is the question. So I have even given in the first 500 questions part 1 also. Okay, so part 1 also I have given this question. So whenever you see these dimensions for L, RC and omega L by R, all these things, what you need to consider? You need to just check so only one thing. Okay, so we know the time constant. Okay, so the time constant L by R for RL circuit is L by R. For time constant of this one is, so this is for the RC circuit, just now we have seen this is the time constant. Omega L divided by R is nothing but, so what you will be getting, this is the, so quality factor you will be getting. Okay, so otherwise let's leave it now. Okay, so what is this 2 pi by omega? So omega equal to 2 pi f we have. Okay, so f equals to, so what you will be getting generally, f equals to omega by 2 pi. So now they are asking about 1 by f. Okay, so like 2 pi by omega they are asking, this is 1 by f, 1 by frequency, which is also called as a time period. Okay, so time period you can consider this. Okay, so time period units are seconds only. So here time constant units are seconds only. So here time constant units are seconds only. So what is this omega L by R? So this is quality factor. Okay, so definitely it will have the different answer. Okay, so different unit. So this is the answer for us. Okay, so if you want you can check for L by R what is the unit, seconds. Okay, so seconds will be the unit for this one. For omega what are the units, you can check from here. Okay, so like one by one you need to derive. Okay, next one, an ideal voltage source should have, okay, voltage source they are asking, large value of EMF, small value of EMF, zero source resistance, infinite source resistance. Okay, ideal voltage source. Okay, so voltage source means zero source resistance. Okay, so here we need to remember something, voltage source and internal resistance, ideal. Okay, so ideal voltage source. Okay, so internal resistance Rs equals to 0. That's why we used to do the short circuit. Okay, so for practical, okay, so for practical Rs must be, so as minimum as possible. Okay, so as minimum, okay, so as minimum as possible, R, okay, so as minimum as possible, R we can consider very low value. Okay, or small value. Okay, so small value. Okay, and you need to remember one more thing. Okay, so whenever it's a voltage source you need to connect in series, the internal resistance must be connected in series with it like this. Okay, so this is Vs and this is Rs. Okay, so if you want you just take the screenshot. Okay, so this one, so very important, simple question only, but half of the people, okay, so remember half of the people will do the wrong answer, this small question also. Okay, so that's why I'm just mentioning again. Okay, so this IS, current source and internal resistance. So and how we need to connect this one, so current source means you need to connect as a current source value in parallel with resistance Rs. Okay, so between the terminals these two. Okay, so this is IS value. Okay, for ideal current source, okay, so for ideal current source Rs value, okay, so our internal resistance or source resistance, it will be equals to infinity. Ideal, okay, ideal means whatever current is coming like this, everything need to go to the load only. If you connect anything here, everything need to go to the load only, nothing should go like this. If nothing should go, that's what, right, ideal case. Okay, so no current should go inside means it has to be a open circuit. Okay, so that's how Rs value it must be infinity means open circuit. Okay, so now practical. Okay, so practical means definitely some current or some losses will be there, because of that some current will has to go here. Some current only we want, not like more current, because all the current should be utilized by the loads. Okay, so that's why very less current for the practical sources will be going to the internal resistance. Okay, so very less current has to flow means Rs value must be high value. Okay, so Rs must be high or it must be very high. Okay, so as maximum as possible. Okay, so as maximum as possible. Okay, so that is the answer for this current source. Okay, so voltage source and current source, so we need to understand so internal resistances and how to connect also, like for the voltage, for the current source, how the internal resistance is connected in parallel. Okay, for the voltage source, how the internal resistance is connected in series. Okay, so on this concept, okay, in our original classes also I have given so much of information about this all. Okay, these are the first things we need to understand. Otherwise, how we will be learning all these voltage sources has to be short circuited, current sources has to be open circuited. Why we are doing this voltage source short circuit? Because its internal resistance equals to 0. Why current source we are doing as a open circuit? Because its internal resistance equals to infinity. Okay, that's why we are replacing with that internal resistances. In Thevenin's theorem we are doing this, in superposition theorem we are doing, whenever you are calculating equivalent resistance you are doing, so many other cases, even in the transients also you will be doing all these things. Okay, so why means, so there are certain reasons, these are the actual reasons for that. Okay, and the next question is, the current I in the circuit shown in the figure is, okay, so current I they are asking. So here whenever you see this kind of question, how to calculate this? Some may think, okay, so I will apply nodal analysis V1 V2 and this I will choose as the reference node, then I will do. Okay, so what you will get from this one, you will get more calculation and you will waste more time. Okay, so whenever you see, immediately you will not get the proper method to solve. Okay, so whenever you practice, you will definitely get. Even whenever first time I am seeing this question, so I will be thinking for 2 or 3 seconds which method will be best for this one. Okay, so like you see current source in parallel with resistance, current source in parallel with resistance, we can convert these two, yes or no, we can convert these two as a voltage source in series with resistance. We can convert like that easily. Okay, so that means 2 in parallel with 2 we have, then you will be getting I into R as the new voltage source, that will be 4 volt, and here we have one resistance of 2 ohms, and here actually we want the current in this 2 ohms resistance, and here again 8 ohm resistance will be like this only, and here we have a voltage source, so that will be 7 into 8. Okay, so 7 into 8 is nothing but so 56. Okay, so 56. How I am giving plus here and minus here? So that means current direction is upwards, so we need to give plus up and minus down. Okay, like this. Okay, so this is the entire network we have. So now what you need to do, you need to just do the simple calculation only. Okay, here on another current source also there. Okay, so this is 4 ampere current source like this. Okay, so and they said here current I. Okay, so here current I they have mentioned. So for the easy calculation, what I will do, I will assume here current Ix. Okay, current in this one will be Ix, I will be choosing. Okay, so for easy calculation, one loop equation I am writing, minus 4 plus 2Ix. Okay, so next what is the current here? I they have mentioned. Okay, so I they have mentioned. Otherwise, why to do this Ix also? Okay, so instead of this Ix, we can just get the relation between these two also. Okay, so let's write down. Okay, so plus 2Ix plus 2I plus 8Ix. Here Ix means here also Ix only. Okay, so 8Ix plus 56 is equals to 0. This is one equation. Okay, so totally we will be getting 10Ix plus 2I is equals to 56 minus 4 will be 52. 52 other side minus 52. Okay, so this is one equation, but another relation also we need, right? Okay, so like you see here one junction is there, current going here is Ix, current coming is I, going is Ix, and going is also 4. Okay, so that means I equals to, okay, so I current is coming and 4 and Ix is leaving, so Ix plus 4. Okay, so what value you want? I want I value, so Ix I will substitute in this one, that will be equals to I minus 4. Okay, Ix value equals to I minus 4. Okay, why to choose this Ix again? Okay, directly here only we can give in the beginning also. Okay, so just for analysis I have given, so I will substitute Ix value is I minus 4 here, so then for 10I minus 40. Okay, so 10I minus 40 plus 2I is equals to minus 52 it will be. Okay, so minus 40, if it go to other side, then you will be getting minus 12 other side. Okay, so total it is 10I plus 2I, 12I equals to minus 12, I equals to minus 1 amperes. Okay, so this is the answer. Okay, so even in a simple method fast you can how to do this, this might have taken only 1.5 minute to solve. Okay, so but if you for explanation it will take definitely some time. So if you practice within like 1 minute only, you will be getting this answer. Okay, and there are so many other things also that you can. Okay, so see here, I equals to 1 ampere minus 1 ampere, right? That means 1 ampere current is going like this. Okay, so 1 ampere current is going like this. Okay, so we need to check some more things. Okay, see here 2 amperes current is coming like this. Okay, so let's leave this circuit now. Okay, so no need of this circuit now. So here 1 ampere current is coming like this. Okay, so 2 ampere current is coming like this. 4 ampere current also coming like this. Okay, so total 2 plus 4 plus 1 equals to 7. Okay, so here 7 ampere current is going like this. Okay, so here also you can check. Okay, 7 ampere is coming like this, 1 ampere is leaving, and 4 amperes also leaving. So remaining will be how much it is, 7 amperes, and 5 amperes is leaving, means 2 amperes must leave here. Okay, so like this. Okay, so and one more thing, if you can check this. Okay, so 2 amperes is leaving here, 7 amperes is coming, 2 amperes is coming, and 7 amperes is coming. So 7 amperes is leaving. Okay, so total it will be balanced here. So we can check one thing. Okay, so anywhere in the circuit, okay, so just see, anywhere in the circuit, if you draw like this, okay, any line, okay, it will not be useful now for this question. Okay, but you can implement in a, if you are not getting answer properly within time. Okay, at that time you can apply this. Okay, so I am just drawing one line like this. Okay, see here 2 amperes is entering. Okay, so here 7 amperes is coming. Okay, so like this, here 2 amperes is coming like this. Okay, so here 7 amperes will be going like this. If you add all these things, you will get 0 only. Okay, so 0 amperes. Understanding? Not only here. Okay, so anywhere, any line you can draw cross, or you can draw any other thing also. Okay, so like let me draw here like this. Okay, so anything. Okay, so anything like this. Okay, so you can draw anywhere. Okay, see for this line here. Okay, so points will be mentioning for otherwise we will be confusing. Okay, so these 4 points, you see here how much current it is. Okay, 4 amperes is coming like this, 4 amperes. Okay, so next here 1 ampere is coming like this side. Okay, so 1 ampere is coming. Okay, so next 2 amperes also coming like this, 2 amperes also coming like this, and here 7 amperes is going upwards, 7 amperes. If you add all these things, again you will be getting 0 ampere anywhere. Okay, for example, if you don't know this current, you know these 3 currents, directly you can do this one, right? Okay, so this is just implementation of KCL only. There is nothing new here. Okay, if you observe, we are applying KCL here, that's it. We are applying KCL there, that's it. So previously what we are doing here means, for these 4, okay, for these 4 branches, the common node is here. Okay, so we are applying a KCL here in the previous case. Okay, so like this also we can able to do. Okay, so these are very very important things. Like you may not get now this interest to solve like this, but one day it will be useful for you. Okay, next question, as per the concept of analogy between electric and magnetic circuits, dash is the analogy pair. Okay, so analogy pair they are asking. So field density, okay, so and field intensity, so both are related to magnetic circuits only. Okay, so current and charge, current in the electric circuit, and instead of charge it has to be flux in the magnetic circuit. Okay, so they are asking about magnetic circuit only. Okay, so next, so this option is also wrong. Okay, field density and field intensity. Okay, so density is field flux density they mean. Okay, so B and H. Next, conductivity and permittivity, conductivity and permeability. Okay, so here some people may confuse, what is this permittivity, what is this permeability. In these 2 options only one will be correct definitely. Okay, so permittivity is related to dielectric property. Okay, permittivity is related to dielectric material. Okay, so and permeability is related to magnetic. This is enough. Okay, so this is enough to answer this directly. Conductivity is related to permeability. Okay, so as analogy in the magnetic circuits is permeability. Okay, so directly we can answer like this. Okay, and the next question, 4 parallel resistors connected in parallel with 5 series resistors are connected to a DC supply of, okay, so 210 volts. If R is a resistance of each resistor and supply current is 5 amperes, so then the value of R is, okay, what they have given, certain conditions they have given for the connections. To waste the time only they have given like this, okay. They can give the circuit, and this model of questions definitely they will give in the exam, okay. 4 parallel resistors connected in parallel with 5 series resistors, okay. So that means 5 series resistors are like this, that means 5R is there, okay, 5R it is, and so they have mentioned 4 parallel resistors connected in parallel with, okay. So here 4 resistors connected in parallel means R by 4 you will be getting, okay. So this is the connection of resistances. R connected to a DC supply of 210 volt, okay, so 210 volt. Okay, so this is what they have mentioned, and they told the supply current is 5 amperes. Okay, so now they are asking about the value of resistance. Okay, so these two are connected in parallel, so R equivalent you will be getting as 5R into R by 4. Okay, so 5R into R by 4 divided by 5R plus R by 4 you will be getting 21R divided by 4. Okay, so 4 will be cancelled. So here R and R also cancels. Then you will be getting as 5R divided by 21. Okay, so this is R equivalent. 5R divided by 21. Okay, so this is R equivalent. So now this R equivalent 5R divided by 21 equals to 210 divided by 5. Voltage divided by current it is. Okay, so anyhow, so 5 into 5 is 25 you will be getting, and 21 into 21. Okay, so what is 21 into 21? So 4. Okay, so 21 into 21 you will be getting as, so 441. Okay, so 441 is 21 into 21, and into 0 is also there, divided by 25. Okay, so this is the resistance value. Okay, so now you need to divide this one. Okay, so with 5 we will be dividing. Okay, so 5 cities. Okay, so and 5 8s 40, and again 5 8s 40, and 5 2s it will be, so 5 2s it will be 10. Okay, so it's correct only. So R we got as from the option only I have seen and answered. Okay, so 882 divided by 5. Okay, so this is the answer for us. Okay, so this connection only. Okay, so previously, so when I am doing this one I have did wrong. Okay, at that time, so later I have realized. Okay, so connection of circuit I have taken as a different, that's why so we got different answer previously. So that I have not given for you. Okay, so this is the correct answer now. Okay, so whenever you see this kind of question, so see properly, otherwise you will definitely confuse and you will waste more time also. Okay, next one, the power dissipated in watts in the resistor R is. Okay, so in the resistor R they are asking about power dissipation. Okay, so here I know already this is a 6 ampere current source it has to be. Okay, so what we need to do immediately, whenever you see current source in parallel with resistance, convert into voltage source in series with resistance. Okay, so you will be getting as a 60 volt in series with 10 ohms, and here already resistance R is there, and here 6 ohms of resistance is there, and here you will be getting, so how much, 6 into 10 is here also 60 volt. Okay, so like this we got, so here 60 volts is there and here 60 volts is there, so between these two no current will be flowing. Okay, so I equals to 0, like this we need to answer. Okay, so may not be same question, so this kind of question they may not ask again, but what we need to see, they may ask, okay, so the current flowing in the resistance R equals to 0, then what is the value of this, like that they may ask. Okay, so current going in the resistance R equals to 0, then what is the value of this current source Ix? Okay, so like this they will ask, so according to that you need to choose. Okay, so this will be the next kind of questions they may give. Okay, next one, the Norton resistance of the circuit shown is, Norton resistance they are asking. So directly voltage source we need to short circuit because its internal resistance is 0 ohms. Okay, current source we need to open circuit because its internal resistance is infinity ohms. Okay, why we need to represent internal resistance here? Because we want resistance, equivalent resistance. So resistance of this is infinity, resistance of this is 0. Okay, so then 4 in parallel with 12. Okay, so remember one thing, 4 in parallel with 12 means you no need to do like this. Okay, so 4 into 12 divided by 16. Okay, so 4 ones, 4 fours. Okay, so here we will be getting 3. Okay, so that is the answer. Okay, so 3 ohms, this is the answer. No need to do like this. Okay, so you have to remember some things, like 3 ohms in parallel with 6 ohms, what you will be getting. So 3 into 6 is nothing but 18 divided by 9, so you will be getting 2 ohms. Okay, so these values are fixed. Okay, in our problems this kind of values will be coming, and you need to know. Okay, so whenever parallel these are, so easy values only they will be giving like this. In this question also they have given similar way. So whenever these two are there, immediately you need to know, okay, 4 in parallel with 12 it is. Okay, so what you will be getting, 3 in series with 1, so you will be getting as 4 ohms. This is the answer. Only 10 seconds you need to take. Okay, so not much. Short circuit, open circuit, I will redraw the circuit, all these things no need. Okay, directly we need to answer. Okay, so not only here, so resistance, if you want you can calculate the current also. Okay, like Norton current or Norton voltage or Thevenin's equivalent voltage, you can calculate for this one. Okay, so for the calculation of voltage, I will just give you the idea. Okay, how it is. See, here one voltage source is there, voltage source in series with resistance, we can convert as current source in parallel with same resistance. Here 4 ohms will be coming, 32 divided by 4. Okay, so it will be 8 amperes. Okay, so 8 amperes in parallel with 4 ohms in parallel with 12 ohms in parallel with 2 amperes. 2 plus 4, 2 plus 8 amperes, so total it will be 10 amperes of current source in parallel with, so 4 in parallel with 12 you will be getting. So that means here 3 ohms we have, and here it is 1 ohm. Okay, so this is the open circuit. This is the entire circuit we have now. Okay, so now you can just simply 10 amperes in series with this 3 ohms. Okay, so this is enough. 10 amperes in parallel with 3 ohms, you will be getting as, what is the voltage source value, 30 volt. Okay, so in series with 3 ohms and another 1 ohm is there, so it will be 4 ohms. So directly, so you got Thevenin's equivalent voltage, we got Thevenin's resistance or Norton resistance we got. If you do short circuit, what is the short circuit current or Norton equivalent current? 30. If you do the short circuit, 30 divided by 4, so it will be 7.5 amperes. Everything we got with only one simple calculation. It is source transformation we have did. Okay, so that's why which method, if they ask only resistance, then no problem, directly we have solved. If they ask two values, what is the Rn and In, for example. Okay, so if they ask both, so like 4 ohms and 7.5 amperes, like this you will be getting. Understanding? So no need to worry about if two values are there in the options. Okay, no need to worry. So you need to choose the best method to solve this kind of questions. Okay, next one, the alternating voltage sinusoidal across the current through current through a circuit are represented by A plus JB and C plus JD respectively. The power in watts is given by. Okay, so voltage they have mentioned, it's a sinusoidal voltage, AC voltage they have mentioned, and current through the circuit. Okay, so both they have mentioned as A plus JB, C plus JD. Okay, so the power in watts they are asking. Watts means active power or reactive power? It's a active power. Okay, so anyhow the entire apparent power will be, apparent power we can give it as, so V into I conjugate. Okay, so this formula we can give. Okay, so what is V? Voltage they have mentioned as A plus JB and current they have mentioned as C plus JD, but conjugate of that, so C minus JD. Okay, so you need to multiply AC. Okay, so A into C, next minus J into, so AD. Okay, so next C into, so this one. Okay, so J BC. Okay, so minus J into J square will be minus 1, so you will be getting plus BD. Okay, so these are the entire all four terms. Okay, so these are the real terms and these two are the imaginary terms. Okay, so if you can separate these two, AC plus BD plus J into, okay, so AD minus BC, so otherwise so you can give it as plus J into BC, okay, so BC minus AD, okay, so like this we can give, okay. So this is the entire apparent power, and this is nothing but our active power P, and this is nothing but our reactive power Q it is, okay. So active power and reactive power, okay. So it may be, okay, so plus value and minus value, no need to worry, AD minus BC or BC minus AD, it depends upon the values only, okay. If you use here minus, then it will be reversed, okay, so no need to worry about that, okay. So AC plus BD will be the answer for us, okay. So AC plus BD will be the active power. They are asking in terms of watts, because active power units are watts, or kilowatts, or megawatts, or so gigawatts, okay. So we are generating this power, okay. So we don't want to generate this reactive power. For the balancing of all these power factors, voltage control, we should definitely need this reactive power also. Units of reactive power is volt amperes reactive, otherwise kVAR, okay. So MVAR, that is a reactive power units, okay. Apparent power, so VA, volt amperes, or kVA, or MVA, okay. So this is the rating of the machines generally we will be observing. So generally apparent power rating, okay. So these are also important for us, okay. Next question, the circuit shown in the given figure is equivalent to a load of, okay. So circuit shown in the given figure is a equivalent to a load of, okay. So they are asking about R equivalent, okay. So R equivalent they are asking, so because from the options I got, okay, ohms they need, okay. So what you need to do, you need to find V by I, that's it. V by I if you calculate, then you will get the R equivalent, okay. So just simply we need to write down one loop equation, okay. So this is one loop equation, I will try to write down, okay. So just think like this is plus and this is minus, minus V, okay. So this is plus and this is minus, minus V plus 2, okay. So 2 into I, okay. So here current we need to know, okay. So what is the current going in this one? If I current is coming like this, how much current will flow like this? This is voltage V, so current in this one is V by 4, okay. So in I, V by 4 current is going like this, remaining current will flow. So I minus V by 4 plus what is the voltage? It is 2I equals to 0. Why equals to 0? Algebraic sum of the voltage in a closed loop equals to 0 according to KVL, okay. So this is minus V plus 2I, okay. So again one more I is there, 2I is there. So total 4I minus, so minus V by 2 equals to 0 it is, okay. So anyhow let's observe what we got. So total it is value only we need to know, okay. Okay, so total we will be getting 4I is equals to V plus V by 2, 3V divided by 2. So we need V by I, okay. So take this I other side. So it will be V by I equals to 4 into 2 is 8 divided by 3, okay. So V by I, which is R equivalent, so which is the load of this circuit, is nothing but 8 by 3 ohms we will be getting, okay. So this is the answer, 8 by 3 is the answer for us, okay. One of the important type of question, okay. So which of the following theorems enables a number of voltage or current sources to be combined directly into a single voltage or current source, okay. So number of voltage sources we can combine as a single voltage source or single current source they are asking. It will be Thevenin's theorem, yes or no? Thevenin's theorem, okay. So Thevenin's theorem, okay. So Thevenin's theorem, what is Thevenin's theorem? Thevenin's theorem is nothing but any big network we can convert as a small network which can have a single voltage source in series with resistance. Similar to this Norton theorem also, any big network we can convert as a single current source in parallel with resistance, okay, between the terminals A and B, okay. So either Thevenin's theorem or Norton's theorem, okay. So these are the answers, okay, for this. Let's see the options, okay. So what we have: compensation theorem, reciprocity theorem, superposition theorem, Milliman's theorem, okay. So here we need to understand something. These three theorems, these two theorems we have in syllabus generally, but compensation theorem and Milliman's theorem we don't have directly in the syllabus, but we should know what is this Milliman's theorem. See the question, okay. I have already explained this in the TS Genco 2015 question paper, okay, question paper explanation. So here again, okay, some more explanation I am giving, not that explanation, different explanation, okay. So Milliman's theorem, what is this Milliman's theorem? So current, any source any source, okay, so any source with another source, okay, so with another source they are connecting in parallel like this, what we can do, we can convert as a single source. It is like resistance in series with voltage, okay, so as a single source. This is Thevenin's theorem only, but what are all these things? These are generator 1, this is generator 2, this is generator 3. All generators are connected in parallel and we can consider as a single generator it is. Just like for example our YTPS power plant is there, okay, so total 4000 megawatt, okay, 4000 megawatt of capacity it is, okay, that is this generator, understanding, but 4000 megawatt capacity generator is not present inside. So we have 800 megawatt generator first one, 800 megawatt generator second one, 800 megawatt generator third one, fourth one, fifth one, like that. All 5 we have, 5 units we have, all are connected in parallel, okay. So now combinedly we can represent as the capacity or as the capacity of that entire power plant is 4000 megawatt, okay. So like that we need to understand, okay. Sometimes you may not operate 2 plants, sometimes you will be operating only 3 plant, like this we need to understand, okay. So anyhow this is called parallel generator theorem, otherwise Milliman's theorem, okay. So definitely this year, okay, so 2023, okay, so our 24 exam will be, so you will be getting this question from the Milliman's theorem, okay. So because some certain reasons are there why they need to give this question, okay. So definitely you may expect the question like this. Next one, the impedance of 2 element series circuit is represented by, so 20 minus J10 ohms at a certain frequency. If the frequency is doubled, the new value of impedance will be, okay. Frequency is doubled they have mentioned. So frequency is doubled means real part will not be changed, only imaginary part will be changing, okay. So real part will not change means real part will not change, real part will not change. But what they have mentioned, so the impedance of a 2 element series circuit, okay. So and here reactance is negative, okay, so negative here reactance, that means it will be a series RC circuit, yes or no, series RC circuit like this, okay. So this is R and this is minus J by omega C, okay. So this is the one, okay. Now what they are asking, so frequency is increased, okay. So frequency is doubled, frequency doubles means definitely what will happen, so frequency doubles means what will happen, entire reactance will decrease it is, okay. So like value of it is minus J5 it is, okay, understanding. If the frequency is doubled, the new value of impedance, so here only one thing you need to understand, here minus is there or plus is there, okay. If it is plus then you will be getting, if it is RL circuit, then the complete impedance is equals to R plus J omega L, okay. So if it is RC circuit, it will be R minus J by omega C, okay. So here minus it is, so this one we need to understand, if frequency is double, so this reactive part will decrease, okay, because it's in the denominator, okay. So that's why answer for this question is option A, okay. So many students they have given wrong answer, okay. So when it is happening Genco 2012, okay. So remember one thing, so 2012 one notification is there, 2015 one notification is there. So previously it used to come, okay, so like 2 years once or 3 years once, okay. So later it has changed a little bit. So in Telangana we are getting a more number of this kind of notification, but in AP so little bit of less, okay. Next, an RLC series resonant circuit has a Q of 15 and a source voltage of 50 volt, the voltage across capacitor resonance, okay. See, these are all very important models. It may be given in the sub-engineer exam only, but this model of question is very important, okay. See, what within seconds you need to do, but 90% of the students will not do this question, okay. So that kind of question it is. So we will learn about resonance, okay, but see, RLC series resonance circuit they have mentioned, voltage across capacitor they have asked, voltage across capacitor is Q times of source voltage, that's it. Q times of source voltage, Q is 15, source voltage is 50, so 15 into 5 is nothing but 75, 750 will be the answer. Directly this is the answer, okay. No need to check. Not only voltage across the capacitor, okay, so voltage across inductor is also equals to Q times of V, okay. So that's also equals to 750, okay. So So value, okay, so value, either it may be, it will be giving voltage or taking voltage. Later stages we can understand it is a plus jqv, okay, it is a minus jqv. Later we can understand, but magnitude only they are asking here. See the options, okay, the voltage across the capacitor at resonance is in the resonance condition, okay, so voltage across inductor and voltage across capacitor will be same, okay, so VL equals to VC under resonance condition. Then what is happening, total voltage across the source will be dropped only at the resistor, okay, so like that it has to be, okay, in a series. And voltage across resistor equals to, what is the source voltage, 50, so it will be 50 volts, that's it. Understanding? But how these three are balanced? So total voltage, source voltage equals to 50 plus j into 750 minus 750 it is, okay, so like this. So source voltage equals to 50 again, okay, so like this it is. Understanding, right? So anyhow answer for this is so 750, okay, that's the answer.